So today we're going to look at some custom data types inside Phoenix Contact's PLCNext Engineer. If you're like me, you like to create different arrays, recipes, structures to use in your code. So in the Phoenix world, that's over here on the right under the Programming tab under Data Types. You're going to right click and hit Add Data Type Worksheet. I've already done that. We've called it UDT. If you right click, you can rename it. So once we open up UDT, we just have a blank workbook. Inside the workbook, we can insert templates like arrays, structure, an array of structure, user-defined strings if the standard 80 character wasn't enough. We're just going to look at arrays real quick. So in here, we're going to give it an array. So I'm going to call it bool array 0 to 10. So that's the name of my array. The array is starts at position 0, goes to position 10, and then we are going to change this to a Boolean data type. If we wanted to create a structure of integers, we could say int array. Maybe we wanted to start at position 1. I don't know why you would want to do that, but it is possible. Then we start typing array, brackets, and then we can start at position 1 through 10 of int. So now we have an array of integers. So those are arrays. If we take a closer look, we can also add structures. Inside of a structure, this is where you can have when you're in programming, you can drill down and get to various items. So if we call this, say, pump, and we have a structure, and we say this is run mode and pump on. So run mode would be an integer, pump on is a Boolean, and then that structure is called pump. So we'll be able to use this in our code here in a minute. So once we've got these data types created, now they're available all over PLCnext Engineer. So I've created a new program called UDT Play. If we open UDT Play, you'll see I have a structured text workbook and my variables editor pinned. So if we go back here, we'll see we created a Boolean array and an integer array. So if we go in here and we type in and we say Boolean array test, now the type is going to be the name of your array. So if we start typing bool, and you'll see we have a Boolean array 0 through 10. So now this this tag now has an array of 11 Booleans. If we do integer, and then we do array, and we do test. If we look here, we also have the same thing, int array 1 through 10. That's a local. And then if we wanted a structure, I could call it something like pump structure, and then we would just need to call it pump. So inside UDT play, we call it pump, and there's pump the structure. So if we were using this, we could say something like Boolean array test, and then because it's an array, maybe we just want to interact with the first Boolean of the array. That's going to be in position 0, and then we're just going to make that true. So now we've interacted with the first position of that Boolean array. Let's try another one. So say I will go outside of the bounds of the array. So let's put in 12 just for fun, and we'll make that false. Now, what we're going to get is we're going to get an error down here for index value exceeds the bounds of the array dimension. So now we know we've actually exceeded the array dimension, and we know that's an improper number, and we can go 0 through 10. If we wanted to do the integers, it would be sort of the same thing. We would say int array test, and then say we wanted position 4 of the array to be 25. Now position 4 of that integer array now has the value 25. If we look at the pump structure, this is sort of my favorite part. When you're building HMI objects, when you're building function blocks, when you're building other items, these structures and then even arrays of structures become a fairly important thing in keeping your code organized. So if I was to say pump struct and then period, now I can say run mode and say when an integer was 2, that was in auto mode. Now I've put pump structure dot run mode into, I've put a 2 into that position. And then if I was to do pump struct dot pump on, maybe that's actually an output. So I could say something like is pump on, and that's equal to pump struct dot pump on. And what that would do is if I had that tag to a variable, it would then fill in that structure. So again, if you have any sort of, say you have 10 pressure transducers and they're all labeled 1 through 10, well, maybe you don't want to have a separate variable for all 10 pressure transducers. You could either create an array of, say, real numbers, and then each pressure transducer goes into the array, or you could create a structure, and you could say, like the first variable in here might be pump pressure, right? And that's going to be a real number. And maybe we also have pump speed, which is also a real number. So now when you're going through and creating all of these various pumps, all of these various pressure transducers, you have some type of structure to keep these in. Now you can also do an array of structures. So if we were to do something like array of structures, so now it's an array, so we can say array of pump 0 through 10, and then it's going to be, we can just, instead of doing my structure, which is down here, we can just simply use pump. So if we put in here and we just put in pump, so now we can get rid of this. So now we have an array of 10 structures. So there are 10 of these structures inside of this array. So if you had 10 pumps, now you have pumps 0 through 10, and then inside each one of these structures, all of this data is sort of sorted and ready for you to use. This is just a brief overview of user data types. Hopefully this helps you in your programming, and I will do an HMI video of how to attach a user data type to some of these web server applications.